Hello and welcome back to Humanizer, where I'm converting the free and open source MakeHuman plugin for Blender into Go.4. So I've already had the skeleton resizing and the mesh animation working. So this all works on the same base mesh and then just uses shape keys and the skeleton data to resize the skeleton. So, and then I'm working on adding everything to the character menu. So currently I have the basic sliders, and then I have all of the micro details, so you can pretty much change everything about the character. And as you can see, there's quite a few options. So I'm working on this. I still need to add the height and weight, so I'll probably do that in a couple episodes. But currently, in this video, I'm just optimizing the SurfaceTool shading generation for the base mesh and the clothing, since I have about 500 more shape keys to import for the macro details. So I need to get this as optimized as possible. And I still have a bit more to do on the import shape keys, and in the clothing I need to cull the extra shape keys. So I still have quite a bit to do, but you can download the current project from the link in the description. And now I'll show you how I optimized the shading. First, I want to fix the bone weights when you use the surface tool. So in this scene, I take the mesh with the imported blend shapes and then use the surface tool to generate the shading for the basis and all of the different shape keys. So in the script, you can see I was trying to fix this using the set bones and set weights by iterating over the vertices and adding them one by one. And this didn't work particularly well because I still had to only use 4 of the 8 bones. So, and I was trying to use this skin weight count, I just didn't really know how to use it. So I'll show you real quick kind of the problem that I was having. So first I'll make a new 3D scene and copy the skeleton and the animation player from the human character. So now you can see that the skeleton is animated. And then from the human model folder, I'll just grab the human resource, which is imported directly from Blender, and then I use the advanced import settings to save it as a mesh. So, and if you set the skeleton, you can see that it animates the mesh. It doesn't actually have to be directly on top of the skeleton, which is kind of cool. And now I'll grab the female casual outfit and this is also exported directly from Blender. So both of these meshes were not modified other than just saving them. And I can attach this to the skeleton as well. So now you can see that both the clothes and the human mesh are animated properly and everything's fine. Now I'll attach a script and I'll make a new function to use the surface tool to copy the mesh, and this will take an array mesh as the parameter. So first I need to make a new surface tool. Then use the create from function on the mesh and surface 0, since the meshes only have one surface. And then I'll make a new variable to commit the surface tool arrays to, and then I'll return the new mesh. And in the ready function, I'll set the clothes mesh equal to surface tool copy, and then I'll pass the import clothes.mesh. And I'll use the resource saver to save the clothes mesh in the test folder as a new resource. So now if I run the scene, it will generate a new mesh of the clothes, and if I attach this to the skeleton as well, you can see that it attaches to the skeleton as well. So now if I try to import the human mesh, so I'll change this to the import human node and save the human mesh as gen human. And I run the scene again. When I add the mesh to the scene, you can see that it was generated, but if I attach it to the skeleton 3D, you can see that it completely disappears. And that's because the bone weights weren't transferred correctly from the surface tool. So, and in the debugger, you can see that it does say that the surface tool has an invalid bone size of 8 versus count of 4. So that is the problem. And if I get the surface arrays from the mesh, mesh.surface get arrays on surface 0, then I get the bone count from the surface arrays on the array bones.size divided by the surface arrays vertex array dot size and then I'll print the bone count. So you can see that the first mesh has 4 bones for every vertex, and the second mesh has 8 bones for every vertex. So basically, to make the SurfaceTool work with a bone count of 8, you'll need to set the SurfaceTool skin weight count to skin 8 weights. So, and if I run this again, you can see that it still has the invalid bone size, and the skeleton 3D still doesn't work. So that's because you need to make sure that you put this after the create from, so it resets the flags when you call this. So you need to set the skin weight count after the create from. And if I run this again, we no longer have the invalid bone weight error, and you can see that the generated human now is attached to the skeleton. So I can move the animation, and you can see that the bone weights are correctly set. Now, of course, if I run the close mesh, it will now have the invalid bone size because it's expecting 8 versus 4. And you can see that the generated closed mesh now is no longer working with the skeleton. So you'll need to check the bone count after you create from the mesh. If the bone count equals 8, then set the skin weight count. And I'm not sure why it can't do that automatically, since it obviously knows that the bone weight is wrong. But now now this should work for both meshes. So you can see that the debugger didn't throw any errors this time, and both the generated human and the generated closed mesh are now working with the skeleton properly. So that works for either mesh. So now in the human character shading script, basically I can get rid of the iterating over each vertex, and before I set the skin weight count, I'll use the SurfaceTool create from the unshaded human mesh on surface 0. And if I run this, it will correctly generate the shading. So that's good. Next, I want to optimize the SurfaceTool shading. So you can see I loop over each shape key from the base mesh and use the SurfaceTool to generate the normals and tangents, and then commit that to the blend shape array and add it as a parameter to the add surface from arrays. So I'll make a new 3D scene, and I'll add the unshaded human. And now I'll attach a new script and make a function to generate the shading from an array mesh. So I'll make a new SurfaceTool and I'll create from the mesh on surface 0, and then I'll use the generate tangents and generate normals. And you do have to call these in the correct order, so it is normals and tangents, otherwise the shading won't work. And then I'll make a new mesh equal to SurfaceTool.commit and return the new mesh. Now on the ready, I'll make a shaded mesh variable equals generate shading on the human unshaded.mesh, and then I'll use the resource saver to save the shaded mesh in the test world folder. So now if I run this and add the generated mesh to the scene, you can see that it has generated all of the shading for the basis shape. So it doesn't have the blend shapes because I only did the base surface. So in the actual generate shading, I do loop over all of the shape keys and use the create from blend shape. But for testing, this will be fine. Now the issue is you only need the vertex and normals and tangents data set in the blend shape arrays, and the output mesh that the surface tool generates has the extra arrays that you don't really need. So if I get the surface arrays from the shaded mesh dot surface get arrays on surface 0, and then I print the surface arrays UV texture size and the bones and weights. So even though it had the invalid bone count, it's still going to populate these with zeros. And I want to get the size as instead of actually printing the arrays. So you can see that there's 14,000 UVs and 58,000 bones and weights. So that's not necessarily a problem. If it was just duplicating the arrays, it wouldn't take a whole lot of time. But the issue is that it reorders the vertex arrays. So if I just print the vertex array size for the original mesh and the generated mesh, at mesh.vertex, you can see that the original mesh has almost 17,000 vertices, but the generated mesh has 14,500, so it lost around 2,500. And I think it was using the optimize function that the SurfaceTool has built in, but I'm not really sure. And I've used the vertex finder on it, and it appears that the generated vertexes are in a completely different order. It's not just that some have been removed. So basically, when it reorders the vertexes, it also has to reorder all of the UVs and the bones and the weights and whatever other arrays that you have set. So you just want to pass in the minimum amount of data to the SurfaceTool in order to make this run faster. So I don't need to print the vertex array sizes, and in the generate shading function, I'll make a new variable for the start time equals the time get ticks milliseconds, which gets the number of milliseconds since the scene started, and then I'll get the end time after it's done generating the normals and tangents, and I'll print the end time minus the start time. So now if I run this, you can see that it takes 311 milliseconds to generate the normals and tangents. Now I want to first make a new mesh from the surface arrays. So I'll make a new array mesh, and then use add surface from arrays with primitive triangles from the surface arrays. And then I'll just call the generate shading again on the new mesh. So this takes significantly less time, and I'm not really sure why, but I'll just call it a second time. So this is about the same, and so that'll be the base point that I'm comparing it to is around 230 seconds or milliseconds. Now I'll set the surface arrays at mesh array bones equal to null, and you'll need to set both the bones and the weights to null so it doesn't throw an error. And then I'll remake the new mesh and add the surface from the surface arrays and generate the shading again. So now you can see that it's gone from 228 to 182, so that's a change of 40 milliseconds. And if I set the UV texture array to null, it will reduce the time even more. So now it's at 103, which is pretty significant. So it's reduced the time by over half from 227 to 103. So basically, you want to set all of the arrays to null except for the vertex and the index array. So I'll make a new variable for the new surface arrays equals a new array, and I'll resize the new surface arrays to mesh array max, and then I'll set the new surface arrays at mesh array vertex equals the surface arrays at array vertex. And you also need to give it the index so it knows what order the triangles are in. Otherwise, it'll throw an error. So these are the only two arrays that need to be set. And then you can use the new surface arrays in the add surface on the new mesh. And I'll set the last generated mesh to a new variable, and then use the resource saver to save that as the generated human. And I'll delete the resource and the node and run it again. So now you can see that it went from 334 to 219 to 98 milliseconds. So this is much faster, and of course it doesn't make a huge difference if you're only shading one mesh, but when I'm generating the shape keys, there's 1200, so this will be quite a big difference. And so it did regenerate the file, and it has all of the shading correctly. And I was curious if running the indexed mesh through the generate shading would make much of a difference. But it seems to take about the same amount of time, so I don't need to pre-order the vertexes before I generate the blend shape shading, essentially. So now that's all working, I'll make a new script extending the resource called mesh shader, and I'll set the class name and make a new variable for the import mesh, which is an array mesh. Then in the init function, I'll add a parameter for the import mesh and set the variable. Then I'll add a new function to make the basis arrays. So I'll need to get the surface arrays to check the vertex count, and so this will be the import mesh dot get surface arrays, and then you'll create from the import mesh And I need to make a new variable for the surface tool. And I'll return the mesh arrays from the function. Now I want this to work with all of the meshes, whether it has 4 or 8 bones per vertex. So I'll get the bone count from the bones array size divided by the vertex array size. And if the bone count equals 8, then set the skin count to 8. Otherwise, it will default to 4. Now, I'll add a new function to run the mesh shader. So I'll make a new array mesh for the shaded mesh. And then I'll get the mesh arrays from the makeBasis function, and then I'll use the add surface from arrays function to add the shaded mesh arrays to the mesh. And then I'll just return the shaded mesh for now. Now I want to make sure this is working, so I'll make a new 3D scene and copy the skeleton and animation player from the bone weights test. Then I'll add the human unshaded mesh and attach it to the skeleton. Then if I reset the transform, it'll line up. Now I'll attach a new script, and on ready, I'll set the shaded mesh equal to mesh shader dot new, and I'll pass the human unshaded dot mesh, and then I'll chain together the run function so you can put this all on one line. You could make a separate mesh shader variable and then set the mesh to the run function if you wanted to. And then I'll use the resource saver to save the shaded mesh to the test folder. And I'll go ahead and run the scene. So it didn't throw any errors and it generated the mesh. If I add it to the scene, you can see that we have the shading generated correctly. So in the original mesh, we do have the blend shapes, and I have not added those yet to the generated mesh, so that's why they're missing. But if you connect the shaded mesh to the skeleton, you can see that it is properly rigged. So that was the important part. So now I want to add the blend shapes, and if I click on the unshaded human, you can see the blend shapes are normalized, but for the shaded human, they are relative, and all my calculations are based on the normalized blend shapes. So in the mesh shader, I'll want to set the mesh to normalized. So I'll set the blend shape mode to normalized. And I also want to clear the surface tool before I return the mesh arrays in the make basis function. So now I'll copy the process shape keys function from the original generate shading scene and paste it into the mesh shader class. So I'll set the, instead of unshaded human, I'll use the import mesh, get blend shape name, and then use a surface tool to create the mesh from the blend shape. And then I want to make the shaded mesh a global variable. So now I can add the blend shape name to the shaded mesh. And I also need a blend shapes array. So I can append the commit array to the blend shapes array. Then in the run function, I'll want to get all of the blend shape indexes from the import mesh and run the process shape key function. On each blend shape. And then when you add the surface from arrays, pass the blend shapes array as well. And I also want to get the start and end times just to compare with the optimized version when I'm done. So I'll print the end time minus the start time again. And in the test mesh, I'll reset the shaded human and delete the resource. So now if I run it again, it does take significantly longer because now it's processing the shape keys. Although I did delete everything except for the base macros folder, so there's only about 20 or 30 shape keys in there right now, but it still takes a while. So it did generate the shaded human. And you can see that all of the blend shapes that were in the original mesh are here. There's probably about 50 actually. So of course that's a small fraction of all of the shape keys, but I was just trying to narrow it down for testing. So, and you can see it was almost 30,000 milliseconds to run. So 29,720. So I'll try to remember that so I can tell how much time we saved. And it does still attach to the skeleton correctly. So just want to make sure that's working at every step. So first I'm going to make a new variable for the import surface arrays and the import blend arrays, and I'll set these in the initialize function. So instead of in the basis function, I'll get these at the beginning, so I only have to get them once. And the import blend arrays equal to the import mesh surface get blend shape arrays for surface 0. Next, I'll make a new array mesh for the light mesh, which is just the surface arrays with most of the data removed. And I'll go back to the generate shading test and copy the new surface arrays, so you resize it to it's like 14 or 15, and then set the vertex and index from the original surface arrays, and then add the array to the mesh. So I'll make a new function to make the light mesh, and use the import surface arrays, and then I can just add the surface directly to the light mesh. So then I'll call the make light mesh function after I make the basis and before I process the shape keys. Then I also need to add the blend shapes to the light mesh before I add the surface from arrays. So I'll loop over the blend shapes from the import mesh get blend shape count, and instead of processing the shape key, I'll get the blend shape name, and then I'll add it to the light mesh. Then I need to make sure that the blend shape mode is normalized. And when I add the surface from arrays, I'll pass the import blend arrays as well. Then in the process shape key, I want to create from blend shape on the generated light mesh instead of the import mesh. So now I'll run the shader again. So this time it took around 14,000 milliseconds, which is significantly faster, but it's throwing a bunch of errors, and when I try to add the shaded human to the scene, you can see that it's not rendering. So what's happening is the number of vertexes in the basis mesh is different from the vertex count in the shape key meshes, because The Surface Tool apparently uses the UVs to calculate the number of vertexes. So, and I think that's because where the UV texture wraps around, so like on the seams of the clothing, the single vertex will have two different UV positions depending on which face it's on. So I think it duplicates the vertices. Anyway, if you don't pass the UV array, then it will collapse and there won't be the same number of vertexes. So you can see that it's throwing the condition array format texture UV is true. So that's not actually the entire problem, but it is a pretty good clue. So if I go ahead and set the new surface arrays texture UV and run it again. So this time it took a little over 21,000 milliseconds to run, which is still significantly less than 27,000, although it's definitely not as optimized. But you can see that the shaded human has now rendered correctly, and the blend shapes are all working properly. And I can set the skeleton to the skeleton 3D, and all of the bone weights were set as well. So this is now as optimized as I'm going to make it for now. So now in the original generate shading scene for the human mesh, instead of having all of this duplicate code, I can just set the new mesh to the mesh shader on the unshaded human dot mesh, and call the run function to get the mesh resource. So I don't need those variables anymore. And I could probably add this to the import shape keys, but I'll do that next time, maybe. It takes a long time to run, and I don't really want to run out of resources or memory, so I don't know. I might combine them into a single file. Next, I'll open up the generate close mesh, and I can replace the make shaded mesh function with the mesh shader run. So I'll paste that, set the output to the shaded mesh and the input to the new mesh, and I'll delete the blend shape, process, and shading functions. So now I should be able to run this, and it should be slightly faster. So it'll print out the shape key names. You can see that I've added, this is about half of them. I still need to add the rest of the height and weight macros. So I'll let this finish. Now it needs to generate the tangents and normals. So that took 48,000 milliseconds, which is significantly longer because it had more shape keys. But if I open up the clothes demo, and I generated the female casual outfit. So I'll just check to make sure that the shape keys and the bone weights all seem to generate properly. So this seems to be working, and I still need to cull the extra shape keys out of the clothing, and I probably need to add the shape keys to the pre-indexed array mesh. So I need to get the proper order of the vertexes from the SurfaceTool. So I'll generate the shading on the basis and then map the shape keys to that, and I think it'll make it faster. And then I can add the rest of the macros, and finally I'll add the automated clothing import, which I do have working. I just don't want to run that until I've got the mesh generation more optimized. And I'm not actually sure if it would be better to just generate the static clothing mesh for each character rather than having the single mesh with all of the blend shapes, because that's going to be a lot bigger in memory if you only have one or two of the outfit. So it probably depends on how many unique outfits you have, but I'll figure that out later. So that's all for now. Thank you for watching and have a great day.